Hey guys, my friend Trevor, welcome back to another video, and today we are going to be discussing the history of pi. And it's been a really important equations being calculated for a large number of years, and now we are going to see what it's all about, where it originated. The ancient Babylonians were actually one of the most oldest civilizations to want to know about the subject, and they calculate the area of a circle by taking 3 times square of its radius, which will give us 3. One Babylonian tablet from 1900 to 1680 BC indicates a value of 3.125 for pi, which is a closer approximation. And there was this document called the Rind Papyrus from 1650 BC, which gives us insight into mathematics in ancient Egypt. Actually, the Egyptians calculated the area of a circle by a formula that gave the approximate value of 3.1605 for pi. One of the earliest calculations of pi was done by a very famous mathematician. You may have learned him from school, and you may remember, one of the most famous words said by him, Eureka. Okay, it's made by Archimedes of Syracuse between 287 and 212 BC, one of the greatest mathematicians of the ancient world. Archimedes actually approximated and calculated the area of a circle using the Pythagorean theorem to find the areas of 2 regular polygons. The actual polygon inscribed within the circle and the polygon within which the circle was circumscribed. Since the actual area of the circle lies between the areas of the inscribed and circumscribed polygons, the areas of the polygon gave upper and lower bounds from the area of the circle. So he made more and more points to calculate more and more digits of pi, which we know an accurate estimate of pi now, but back then, now we can match it up and see how it matches up. And you just have to make more and more points and compare that with the circle on the inside and on the outside, and the more points you have, the more the more accurate and more precise you are. And a similar approach was made by a Chinese mathematician called Zhu Zhongzhi, a brilliant Chinese mathematician and an astronomer. Zhu Zhongzhi would not have been familiar with the Archimedes method because they live much far away. But because his book had been lost, little is known about his work, right? He calculated actually the value of the ratio of the circumference of a circle to its diameter is 355 divided by 113. To complete this accuracy for pi, he must have started with an inscribed regular 24,576 gun, I guess. There's no name for this. As you see, more points, more accuracy. And performed lengthy calculations involving hundreds of square roots carried out to 9 decimal places. Mathematicians began using the Greek letter pi in the 1700s. Introduced by William Jones in 1706, the use of the symbol was popularized by Leonard Euler, who adopted it in 1737. An 18th century French mathematician named Georges Buffon devised a way to calculate pi based on probability. You can even try it yourself. And pi has remained very, very iconic and very useful, and one of the most used mathematical notations. Standing there with Euler's number represented with E and I, the imaginary number. And there have been many iconic numbers like pi, and there's also phi. And all of these have Greek roots, and they're either from the 4 superpowers of mathematical superpowers of the world, which were at that time Persia, Greek, India, and China, partially for a while. And most of the great discoveries came from then, and Europe also had a part of it. And basically, pi is really important, and it's mostly geometric. But E is not geometric, and we'll probably discuss about that in another video. And if you guys really like this video, we could make a part 2 on it, explore further into it. What is pi? See the mathematical side of it. How can you use it? Is it only for calculations, formulas? Can you do much more with it? And we can see that in further context. And we can see, and let me tell you the first few digits of pi. It is 3.1415965359, and some people and a person memorized 78,000 digits of pi. He couldn't bother to take the last zero, but that's a great achievement. There used to be 8,000, and now there are many people trying to memorize it. And not only that, currently there's 22 trillion pi decimal places calculated, and it's called an irrational number. It keeps on going. You can prove it using mathematical formulas. It just keeps on going. It never stops. You just get closer and closer to the answer, but you never get pi as an exact value, unless you choose to write down all the 22 trillion digits, of course. Which I don't assume anyone has to spare time if you're a teacher. You know, you're not writing the 22 trillion digits of pi currently, and it's growing with supercomputers, more modern supercomputers with much more computing power, more time run, more calculations, more formulae. The pi number is gonna keep on expanding. It's gonna become bigger. 22 trillion. We don't know when it's gonna become 23. Bigger and bigger and bigger. They're irrational, and we can never hit infinity actually. And yeah, we get so close to the answer, like we're just an infinitesimal away from the answer, but that infinitesimal becomes smaller and smaller and smaller. We can never get to the actual answer. It's irrational. It keeps on going. So, let's say, but it cannot be expressed as a common fraction. Its decimal representation never ends and never settles into a permanently repeating pattern. And still fractions such as 22 divided by 7 and other rational numbers are commonly used to approximate pi. Actual pi is actually infinite, and you'll need infinite time to write infinite numbers down. But it's elementary. In elementary school, you may have learned it's 22 divided by 7. But as you keep on dividing, as you keep on going and going and going, it never stops. But we can stay to the 9 decimal places and get the correct answer. And the symbol is for pi and phi come from Greek letters, indicating their Greek origins. And pi is also commonly defined as the ratio of a circle's circumference to its diameter. So pi is equal to circumference by diameter. And there is a lot, we can dig deeper and deeper and deeper into this. So if you really like this, and you can comment and subscribe and like, and we can keep on going. If this you guys really like this video, we can make a part 2, because there's so much to learn in the maths world. There's so much beauty to see, and there is just so much to uncover, so much to learn. So we can keep on going with pi. We can do part 2, and that is if you guys will like this, because we haven't gotten too much to the mathematical side yet. And I really hope you guys enjoyed this video. If you did, please be sure to hit that like button. Please be sure to subscribe, and see you all in another video. Bye.